Okay, so a very quick example of using summation notation for something that uh, is helpful in the study of elections. So a little more political science and really not very much math in this example relative to some of our other examples. I just want to talk about the formula for the effective number of candidates. If your interests are in elections, especially kind of comparative elections, you're probably familiar with this way of understanding the competitiveness and the fragmentation of the vote in different elections. Okay, so let me just sort of motivate the need for this calculation with an example here, actually an example of two elections. So in both cases, what I've listed for election A and election B is the vote shares. Okay, so we might call them V1, V2, V3, V4. So both of these elections have 4 candidates on the ballot. So this is in election A, the top candidate got 51%, next candidate got 48%, and then there were 2 candidates with hardly any vote share. Election B, the top candidate got 39%, then 35%, then 25%. The last candidate got 1%. So 2 things to notice about this. If you're looking at a whole bunch of elections, say you've got a whole spreadsheet full of numbers of this form, and if you study elections, you probably have a few spreadsheets like that, and you want to know how many serious candidates there are. If you just count the number of candidates on the ballot, you're not going to get the right answer in either case. Election A, like I'm just looking at that, and that's a 2-person race, right? You've got a very close race between 2 candidates, the first 2 that are getting just over 50% and just under 50%. And then you've got a couple of little nut jobs here who got their families to vote for them and got a small amount of the vote share, but not even enough to affect the result. Okay, so election A, first thing to notice about it is it's not really a 4-candidate race. It's effectively a 2-candidate race. Well, those are the 2 things. It's not 4, it is 2. Election B also, like if you just count how many candidates are on the ballot, how many candidates got votes, there would be 4. That also doesn't seem like it would be right. This really seems like a 3-person race. You've got a fairly close race between the first and second, but the third candidate also got a serious number of votes if the supporters of that third candidate had switched to vote for the one that got 35% of the vote. That would have changed the results. So this really is a 3-way race. So the points that I'm making here is if you just look truly at the number of candidates, first of all, the answer doesn't really seem to be 4. The politically relevant answer doesn't seem to be 4 in either case. Second of all, these 2 elections are different in a way that you'd like to pick up. Okay, so one kind of simple way to handle that would be to sort of pick some kind of vote threshold and say, well, I'm only going to count candidates that got more than 5% or more than 10% of the vote as serious candidates. And that's not a terrible thing to do. It's not always obvious what the threshold should be. And then if you have cases close to the threshold, that can be a little bit problematic. Do you want to really say that there's a huge meaningful difference between somebody who got 10.1% of the vote and somebody who got 9.8% of the vote? So another way that political scientists handle this is by calculating the effective number of candidates. Okay, so ENC. And ENC is defined in a formula that has a summation symbol in it. That's why it's appearing here in Math Camp right now. So the effective number of candidates in an election, you get it by taking the reciprocal of the sum over all the nominal number of candidates. So n would be 4 in our example that we have here of the squared vote shares. Okay. So if we apply that to this situation, let's first just write out what that means in the case where n equals 4. 4 candidates And the effective number of candidates, we calculate that as 1 over the first candidate's vote share squared plus the second candidate's vote share squared plus the third candidate's vote share squared plus the fourth candidate's vote share squared. Okay, so in both those cases, that's what we would be calculating. And so if we do that, then for election A, what do we have? We have 1 over 0.51 squared plus 0.48 squared plus 0.005 squared plus that same thing again. And you can plug this into a calculator or do a little spreadsheet, and you will get the number 2.04. And similarly for candidate B, we can do the same thing. Taking the reciprocal of 0.39 squared plus 0.35 squared plus 0.25 squared plus 0.01 squared. And again, punch that out on your calculator or into a spreadsheet, you'll get 2.96. All right, so just a couple of kind of cute things to observe about that. These numbers do kind of fit the impressionistic reaction that we have if we look at the vote shares that we started with. We said that election A really looks to us like a 2-person race, and the ENC calculation gives us a number that's really close to 2. And that election B really did look like a 3-person race, and we get a number that's pretty close to 3 there. And so this is why political scientists like to use this this number. The one other side point, you could just look at the sum of squared shares. That's hard to say. For anything, whether it's votes or market share or share of money, you could just look at the denominator of this. And in economics, sometimes they do that. If they're like measuring the concentration of an industry, how many firms are in it, they would just add up the squared market shares. It's called a Herfindahl index, if you've ever heard that term. You're kind of capturing the same thing. The cute thing that happens when you take the reciprocal is you get these, when you get an answer that's close to an integer, it corresponds with your intuition about the actual number of candidates that matter here. So you get a value close to 2 here when it looks like it's a 2-person race, close to 3 when it's a 3-person race. And indeed, if we did this with exact 50-50 vote share split, you'd get exactly 2.0 as your effective number of candidates. If you had a third, you'd get exactly 3. If you had a fifth, you'd get exactly 5. So the ENC formula, when elections are perfectly balanced, does give the correct integer answer there. Okay, so that's a little segue into fun things one can do with electoral results, and looking at a formula that you're likely to see at some point in your studies. As I said, the reason why we're looking at it here and now is because it is just a use of a summation notation in a political science context. And the sort of notation-y thing I want to point out as a good point to end on is the difference between the two, actually between the two variables here. So the difference between I and N. Okay. I is the index variable, and it is changing within the sum. It is changing within the case. N is the stopping point, and it is fixed within the case. So in both of these cases, N was 4. If we had another race that had 6 candidates on the ballot, and we had 6 vote shares to square and sum up, then N would be 6. Okay? So again, that's sort of helpful if you find yourself being a little bit overwhelmed by the number of variables you can see when we use summation notation. Just remember that the I is something that is kind of helping us do the sum. It's not something we could say about the case itself or about the whole thing, whereas n is a property of the whole sum. So if we're looking at district A, n equals 4. We couldn't look at district A and say, what does I equal? Because when we're going through district A, we say, well, here I equals 1, I equals 2, I equals 3, I equals 4. But n is the same through. Okay, bye.